So we're here to talk about application patterns and what we mean by that. We're not here, I'm not going to show you any code. I'm not going to talk, mostly all the talks on theories. Sorry, I walk a lot when I speak and I got to remember the camera's watching me. So we're here to talk about patterns and how we use them to solve software problems. Now, one of the things patterns are here for is for you to not reinvent the wheel. They exist for a reason, but they're not something you just go out and do. Something you kind of think about when you're planning the implementation of a product or the implementation of a system. So I'm going to walk you through, oh, lights went out. That was the first sign last time. Oh, look at that. Who wants to play Sudoku with me? So there's two things I want you to walk away from at this talk. You're going to see a bunch of patterns, and one thing I don't want you to walk out with is the concept that, oh, Joe said we have to do this. I'm not going to say anything like that. I'm going to give you a view of about 15, 20 different patterns, like this one on screen. And then we are going to kind of see where they benefit from and where they don't. Because one of the common themes throughout this talk is the old expression, just because I have a hammer, everything is a nail. We don't want that in software development. And the number two is, if I was a good speaker, my name's Joe Guadagno. If not, it was that first guy, Mike Eaton. So remember that when you fill out the evals. I'm going to go through the slides here. Well, hopefully they'll pop up. We need them for visualization. So the first one we're going to talk about is the layered. Hey, there it goes. I didn't pray to the presentation gods today, so I guess we'll see what happens in the room 16. So the first one we're going to talk about is layered. Now, this has many different names. It's been around for at least 25, 30 years. And it's commonly referred to as like the three-tiered or the multi-tier, where there's a front end, a back end, and a middle, or the presentation and the logic tier and the data tier. So as we talk about all these patterns, we're going to kind of talk about them in a fictional application or fictional site where you can buy products from, let's call it asmilez.com or something similar. So if you think about this, the presentation layer in this pattern is the UI. So your cell phone, your TV appliance, not a movie theater projector, a web app, or something like that. And then you have the second tier, the most common tier, called the logic tier. The logic tier does a lot of the brains. Some people call this the management layer. Some call it the business layer. Commonly now it's the services layer. The problem with those words is that they vary a lot because those terms mean different things in different languages and technologies. But for the most part, you can think of this as, this is where all the logic sits for your app to place an order, to look up an order. So I'm going to put in that order for those pink socks that I love so much. It's going to go through the logic layer. And then the logic layer will go through and feed the data layer or the data tier. Now this is where your database sits or some kind of storage, whether it's file system or if you're in the last talk, you're going to bounce it off to an event grid, and then that's going to send it off to storage. But the idea is to kind of start separating those concerns between all the different layers. Now, some of the advantages of this pattern is you start to minimize the dependencies. Your front-end app, the mobile device, doesn't connect to the database, doesn't really care about the database. As long as it can connect to the middle tier to do the work, the middle tier does all the work, which is good because then you don't need your dependencies like a SQL Server client or Oracle client or things like that. It makes your app a lot more testable in theory. I say in theory because sometimes in this pattern, UI validation, which sometimes is considered business logic, kind of bleeds into the presentation layer and vice versa. Sometimes, If you have some older databases, a lot of times in SQL Server, Oracle, you had functions or stored procedures or stored or triggers to kind of do that. Oh, that's even funkier now. It's the Goonies version of Sudoku, I guess. Some of the disadvantages of this is that a lot of times, like I was mentioning, some of the layers start to bleed into each other, where you have some of the data validation moves into the web, into the logic and the business layer or the database layer, even though they're supposed to be separate. And then a lot of times, depending on the group and the size of your team, there's debates on where something should be managed. You'll get DBAs and architects that will say, well, I want all the business rules in my stored procedure because I got to make sure my database is pristine. Then you get others say, I want it in the web layer because I want to make sure that no bad data gets in and stop it at the point. The good thing is there's no wrong answer to that. I mean, in some cases you need it and you should have it at all layers. The next pattern, oh look, our grid is back. The next pattern is our MV star. And it's hard to see that, but think of this as, you know, if you're in the .NET world, it's the model view controller. In some places it's called, or in some places they do the model view presenter. In some it's model view model or MVVM. The general premise behind this is your application is controlled by different pieces. Oh, look at it, we got the view. You start off with the view, and this is the presentation. So we go back, you go www.amazon or Walmart or, wow, now I'm in Technicolor green. This is awesome. You start off with your view. So I go enter www.amazon.com. Something needs to display that home page to me. And this is I'm just going to turn this way so I can see what you're seeing and talk to it. This is responsible for showing you the view. So before it shows you the view, it kind of goes to the user. So we're at the bottom of that square, and it gets context around the user saying, oh, this is Joe. Joe just recently placed an order for socks. Let me show him his order status. So he's got like a thing in the top right. And then he has some things in the cart. Let me show him the cart. But before we get all that, the controller kind of needs to gather all that data. So the controller goes out and says, okay, we got this user Joe who went to the home page. What do I need to get? So the controller is like the brains. It goes out to all these different locations to pull in the data. So it'll get the data in my recent orders, it'll get my name, it'll get anything in my shopping cart so that it can display that. And it then returns a model. And this is where kind of the presenter model, the view model comes in. Now the model doesn't necessarily model the underlying database, and in fact you don't want it to. You just show what is necessary for that view. So in this case, let's say we're on the Amazon.com site. I need to say Joseph because it says hello Joseph up there. It doesn't give my last name, my address, my zip code, any of that stuff. And it shows me like my most recent cart items. So it shows me one or two items in there. It may give me a URL to the product. It may give me a cost, a description, and when it can ship. So those are 4 pieces of metadata versus the probably 600 item or 600 pieces of metadata they track per product. And then the model gets returned to the view, and the view says, okay, here's my model. Let me go take all those pieces so I know I have this view up here where I display his name, this view over here where I put his cart, and then in the, I feel like it's when I move my hands. Keep my hands in my pocket. So start pecking at my keyboard when I need to change. And then the site, see, I move my hand again. See, the cycle continues across, so model, view, controller, user, and so on. Now there's a lot of benefits to this pattern. The biggest is like you get a lot stronger separation of concerns between the two, or between the different layers. Like the controller is the only thing that talks to the database. The models don't, the views don't. They know nothing about each other. The only thing that is known is that the controller, if this happens again, I want everyone to just come up around my monitor and we'll just kind of, I got a spare monitor. We can just kind of look at my laptop. I showered today, so it should be okay. The presentation is, in this particular case, can be reused a lot because you can think about it. If you're restricting the amount of data that comes across, like this hello Joseph, I can reuse that anywhere because all I have to do is make sure I have this little chunk of data so I can reuse those views. It also makes your views very testable, and in some cases your controllers very testable. The next one we're going to talk about is event-driven. Event-driven, you can think of it like, when an order is placed. So when an order is placed, things need to happen. So in our fictitious example, now there might be more things that happen, but for the sake of PowerPoints, keep your hands down, Joe. You can think of things like the account charge happens and we have to do an inventory check to make sure that there's inventory there. Then we have to do a deduction from the inventory. After all that's done, we could then fire off an event like order ready. Okay, we're going to ship the package now. We're going to update the order. So this way of thinking is thinking of things that happen in a series. Now these don't all have to happen concurrently. Like the update order status could happen constantly as we're saying, okay, it's shipped. Now it's in this city, now it's in that city, now it's at your neighbor's door. Oops, we made a mistake, now it's back at your door. That kind of stuff. There's lots of tools and frameworks that help support this model, and it's starting to become really popular with things like Kafka and Akka, and if you're in the last talk, the event bus. One of the things that this buys you is you start to decouple yourself away from everything that's happening. So if you think about it, I'm sure a lot of people in here wrote a basic CRUD application, create, read, update, delete. And what ends up happening is when you do a create, there's usually some kind of method you call. You probably do some business logic validation. You then do a check for the order, make sure it's there. Then you write it to the database. Once all that's done, you get an order number, then you pop back. And the next thing that happens is your sales guy comes across and says, oh, we want you to check this other table now to see if they get a customer discount. Or, hey, we're changing our shipping provider now from UPS to FedEx. So now you have to change all your code. The good thing about event-driven architecture is you can say, hey, an order is placed. And then these little individual boxes, you can think about them as services that do the work. So when you place an order, you can only say, hey, an order is placed. Then these things are listening for these events. They're listening for an order placed. Said, oh, an order is placed. I have to go make sure I can charge the account. Goes and charges the account. I have to make sure I check the inventory. Does that. When it comes to shipping it, oh, we changed from UPS to post off to FedEx. I just swap out the component. The user doesn't care about it. They don't need to know. Well, they need to know where it's coming from. But from a software development standpoint, you don't really have to change anything, assuming the contracts don't change from here back. But that's the other beauty of this pattern. If you create the contracts between these, like what an order place look like, what the result of a ship package looks like, you're not changing your code as constantly. You're only changing the bits and pieces that are relevant to that. So in this particular case, our ship package, we can replace the guts to swap out the UPS calls and put in the guts for a FedEx call. Or an even better way is to build a separate event that listens for that ship package and goes next pattern, hopefully the screen doesn't come off, is a little bit different. This is CQRS, which stands for Command Query Responsibility Segregation. Now I had to write that down because I always forget what it stands for because most people just say CQRS. And the idea behind CQRS is there's two sides to your application. Think of a virtual line split right down here. Okay? And I will zoom in a little bit so we can see each section that we talk about. So let's go here. So up front, we're going to start with this user interface. So we start with our Amazon.com. I go to type in Amazon.com in my browser. We then, I don't want to say we call a command bus, but we essentially throw a command on this bus, which is basically a data store, and say, hey, Joe's visiting the site. What do I do? Then you have these things called command handlers that say, oh, I know what to do when someone is looking at a site. It'll go out and do those things. They then start to work with their domain model. So each command handler has a domain model that they're used to. So when someone posts on, I need someone to know about this site, it says, okay, you're going to pass in the person's name, maybe their internal identifier. It'll then take that and start processing it, going through the assorted different repositories, and then putting things in what's called an event store. So the event store tracks a history of all the events that happen. So think of it like a black box that's in an airplane. This is sort of the black box of your website or your application. It basically tracks the history of all the events that happen. So in the event of a failure, you can play back the history to see where it failed, like where data got corrupted or which events did not happen to call it. And this is super helpful in a lot of events. So that's the command side. The query side now is this side. Now this separates out all the query parts of it. So, and this is important for a couple of different reasons. So the whole idea of this is you're separating all the write activity, which is all the commands, in one location. See, I told you, close to there so you can bail out. Holds all the stuff in, all the write stuff to make your application be able to accept those orders a lot faster. Then this part is kind of the read part. It holds all the queries. So it says something like, hey, give me the update on my last order. So it kind of goes through this query facade and then the data layer and handles those kind of requests. So it says, okay, select star blah, blah, blah from orders. And then it's going to handle that event. So these are still triggered like events. And then at the bottom, you see that we have this event handler and event bus. And that's because these two systems tend to talk together, but they talk through this event bus. So the database, as you see, is nowhere listed here. There's a repository here where all that data is. So this event bus will handle the messages saying, hey, we got a query against this data store for this event. It's going to go through this and then eventually populate it back up. The reason why you do that is because you can kind of segment out the infrastructure of your team. You can put more resources at this, because you want more orders coming in and less resources at the reporting of those, like the annual sales reports and stuff, because those don't happen that often, and they take away from the potential, or they potentially take away from the resources in the command part or the write-only part. As you can tell, a lot of these start to get a little bit more complicated than the last. This pattern is very common for highly complex applications. So if you're building a real retail site or e-commerce site, you're most likely going to use this pattern. Now, you don't go out you don't go out and start your app saying, oh, we're going to use CQ or else. You start following these patterns like the command bus and command handling and things like that. And then you naturally start to see that you have that. One of the other advantages of this is pure performance, because you can start segregating out the reads from the writes. And if you really get into it, you can have a read-only version of the data store that just handles the reporting of your orders. So once it's written, the order's there, you can sync it off to another, that this way it doesn't kind of take down the actual order request. Some of the disadvantages of this, it's kind of overkill for your basic, read-only or your basic CRUD application. So your basic, create, read, update, delete. So if you're writing, the next version of Outlook or, something to track people in your friends group, it's overkill. Data can become stale in this if you don't do it the right way, or if you overcompensate in one area than the other. So you see right here, there's back and forth. And when I mentioned, if you can have a separate read-only store here for all like the order history. If you're not synchronizing them fairly regularly, they can become out of sync. So someone's going saying, hey, where's my order? They're doing it, let's say, 30 seconds after, but you're only syncing every 5 minutes. They're not going to see that, which could lead to, other problems. There are quite a few applications or plugins or frameworks that do this in the .NET world. End service is one of the most common ones. They can handle a lot of these patterns, or a lot of this pattern for you. The next one is kind of a combination of the last two. So this is CQRS versus event sourcing. So with this one, let's just do a quick zoom in on top to show you. The top is just clients, network. Don't really focus on the network part. What you're really going to focus on is the next layer, which is the remote facades, as you see here. These guys here. And what ends up happening is, in this scenario, these remote facades are basically putting out these little endpoints out in the world that say, I'm going to handle whatever. Think of them as like the command thing. So I'm going to handle any queries on order status. I'm going to be able to handle create new orders. Then they're going to put them in an event store. And then there's an event bus that sits here and handles those requests. So we get the, hey, who can handle getting Joe's last order? Something comes up and says, oh, me, pick me. And then that thing gets picked, and it creates that event. You see the repository here, it kind of writes out that event. The event store puts that event there, and then it goes to the event bus. And the event bus just kind of drops it on there saying, hey, there is a new request for an order status. What do I do with it? And then it's going to go and check whatever database is, blah, 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 and return the data upwards. Now, it's the same kind of on the right side of this, except this is commonly used for those direct reads. So if you remember in the last pattern, I was talking about how you do reads on one side and writes on the other side. This is kind of the read side for it. Any questions so far? I've been babbling, and yes, sir.
What's the difference between the event side and the command side if they're both making
So the question was, what is the difference from the event side versus the query side? So the event side is meant for more write-based actions. So stuff that is more I/O intensive and stuff that's more critical, whereas the query side is the less critical. Like if it takes an extra second to get back and return someone's order status, so be it in a lot of cases. Outside of that, there's no real difference. They both function the same. The difference is really between this pattern and the previous two is kind of the conjoining in this middle part that kind of does a lot of the orchestration between the two. And the other is up in the cheap seats. This feels really awkward, but I have to block out those two lights in order to see everything up there. What do you mean by destination? So your question is this responsible for making sure the right destinations, it's reading from the right or writing to the right places? Is that your question? Okay. So yes, these event handlers that are here basically are that. The subscriber says, I want to subscribe to the shipping messages. And it knows how to interact with whatever tables it needs to store or retrieve or API services. So yes, these are what actually goes and gets the data for apps or saves it or adds it. That answer your question? Uh-huh. I charge $14.95 for the second question, just be warned. No. So you think of it like, so the question was, is the data in the event store the same as the database? Uh, think of the databases as just data. It could be a web service. It could actually be a physical database like a SQL server. It could be a file. It could be anything. That's where you're going, where the event subscribers are going to get or put whatever data they're responsible for, like the order shipping. They're responsible for calling out to FedEx and then saving whatever tracking numbers. The event store stores the chronological history. So if you use the Windows machine, think of the event store like the event viewer. It says, okay, user logged in at 1 o'clock. The computer was ready at 1:02. They opened up their email at 1:03, etc. So it's like an audit trail, so to speak. And those events do get translated into something that involves a database save or a database lookup or what have you. So they're very different. They serve different purposes. Okay, it's $49.95 for the next one for you, by the way. Any others? Cool. Okay, next one we're going to go into is called the plugin architecture or microkernel. Now, almost everyone in this room, I can guarantee, has used this pattern or views an application that uses this pattern. This is this pattern's been around for a long time, and it's a way to write your applications so that they can accept libraries to do work for them. So you think of things like Microsoft Office. Excel has a bunch of plugins. There's a data import plugin. There's a pivot table plugin. There's a bunch of others. If you're in the .NET world, you use the NuGet package. That's following a plugin architecture. You're adding in value or you're adding in features to your application via some sort of extensible source. In the earlier days of .NET Framework, there was MFC. No, not MC. I think it was MFC. There was a product that was created by Glenn Block that basically allowed you to write these where you can add plugins. This is something very common. Let's say you're writing an application that handles a lot of data. So something like I worked for a company that handled telemetry for data centers. So it tracked like temperatures and things like that. We wrote a bunch of plugins to be able to take that data and export it out to things like Excel or CSVs or Oracle or SQL Server. The idea is you write one you write an interface to something, and then that something kind of you can pass off the work to. So if you think of it like, how many people in this room are .NET developers or Java developers? Okay, almost half the room. The other half is probably too tired to raise their hand. Think of it as an interface. So if you've worked with ADO or Entity Framework, those follow the plugin matters, because when you're writing out to whether it's a SQL or an Oracle database or a SQLite database, you're writing the same commands. Any framework is just kind of translating them for you because there's a common interface. This interface is just that. It allows you to do it. Another common approach for this is for you to create extensibility for databases. So this is commonly done through the repository pattern, where you write out saying, if you want to be able to, for me to use this, you need to implement a save, get, a list, and whatever other methods, and then you can just have a plugin to implement those methods to connect to an Oracle database or connect to a SQL database. So the plugin mechanism is a way to tie features in. Now in this poorly written example, because I couldn't think of a better one to do it, we have the application that has a inventory plugin, an account component, a order component, and a shipping component. Now these handle all the things. So you can imagine your website loads up and says, I need a shipper. It goes to the shipping component, which we happen to be using UPS. And then we decide we need to change it to FedEx. We kind of pull out that plugin and put in the next plugin. The next one was all the rage in 2000. I'll give you a clue or see who knows what it is. I'm sure everyone can guess it. If you guess SOA, or microservices, or service-oriented, you win the prize, which is a free movie at 5 o'clock in theaters 1 through 13. So the idea behind service-oriented architecture was that you were supposed to break out all these services into their own individual service. So the idea of our Amazon site would go through and look for an order, look for account service, look for or I shouldn't say look for. It would have an account service registered. So it had an interface, a contract that said, okay, in order for me to do accounts, I need you to have a get customers, delete customer, look up customer, that kind of stuff. For your inventory, I need you to have a get inventory item, get list of inventory, searches, things like that. So these act as services. Now the reason why I said before that in the middle tier sometimes occur the manager layer, the service layer, the middle tier, was because the word service gets thrown around a lot. The service-oriented architecture pattern, a service was commonly referred to a web service, but it doesn't necessarily have to be that. The idea is you start defining or categorizing levels, not levels of effort, but grouping of work. So here in our example of shopping, we have account service. So it alone is responsible for all the account services. Now the problem with this, or one of the problems with this, is what ended up happening is a lot of people would say, oh, when I ship something, I'm just going to look, the inventory is going to, the shipping service says, oh, I'm just going to go directly to the database that the inventory service uses and just read and write from there. Problem with that approach is you broke this separation of concerns. This service here should never interact with the data here or data here and vice versa. You should only go through the calls of that service, whether that service is a stored procedure or an API or a NuGet package. The reason why you want to do that, or the reason why you want to avoid going in between, is because that unit, so in this case the inventory service, owns its data. So if it has to make some changes due to a new business requirement, let's say it renames a table or changes the name of a column or adds a new column, now the shipping service has to be involved, and that shouldn't be the case. you should talk through contracts through this particular or through this mechanism. And that's why a lot of times the service-oriented can fail, because a lot of people just turn it into it's a term I've heard, a service-oriented monolith. So it's all just one backend database, because a lot of cases it will share the backend database. So a database developer or an engineer can say, oh, I know I can go to this table. I already have a connection to the database. Let me go directly there versus going out. You kind of break those lines. Oops, sorry. The next one is the common microservice pattern. So these are kind of an amalgamation of multiple different ones. This is, you can think of this if you are building or trying to build a new application while an existing application exists. So think of it like we built Amazon.com on AS400, and it uses IBM message queue, and most people have to interact with it through a green screen terminal. And now we want to modernize it and use our AWS backend for storage and use message queues and so on. So this kind of walks you through at a high level how you can start replacing some of those. And it uses a lot of cool terms. So we'll start off with this, with the leftmost, which you see as client application. Then there's this API gateway, which has 3 other patterns in it: gateway offloading, gateway routing, and gateway aggregation. All those are basically a fancy way of saying an API manager. The gateway offloading does that. It's kind of like your load balancer, your F5 or your Amazon or Azure front door. Gateway routing is just that. It's taking your calls and sending it off to the correct server. And the gateway aggregation is just kind of summarizing all that. We'll come back to the strangler pattern after. And then you have this BFFs, which is not best friends forever. It's backends for front ends. Now the idea behind this is you start to develop different APIs just for the front end. So if you go back to our early example with MVC, we had 3 different chunks of data. You had the user information, you had the cart, you had the general recommended products. Well, you can make the front end call 3 API endpoints, or you can make it call 1, and that one kind of goes and does the 3, but it only returns back that smaller set of data. This is becoming a more and more common pattern because it's a lot easier to fine tune. Because if you have a website, the content and data you display there might be a little bit different than on the mobile app. You might want to display less, or different style sheets, or far less data because you have a much more condensed real estate. So that's why this pattern is starting to work in a lot more cases. You're only returning the data you want, and you're keeping the front end from having to update and know every single API. Then you have this sidecar ambassador around this microservice. So the sidecar, you can think of it as kind of your logging telemetry layer. So this is sitting on top of your, not on top of, but within your service and starting to tell you about metrics for the app, like it handles your logging, your telemetry, how many calls in, how many calls out, etc. And the ambassador is just kind of all the underlining architecture, find it, CPU usage, memory, all that. Then you have these 2 here, the strangler and the anti-corruption layer. No, these are not for government websites, it's just a general term. The strangler pattern is kind of like your middle guy as you're starting to rebuild it. So the strangler says, okay, this API is available in the new API, so go there. Or it's not, I have to go to the legacy system to get it. So the strangler kind of wraps around your application and knows where to go, and eventually that strangler becomes not needed because the API or your application just goes back. And this anti-corruption layer, it's a poor name, but the idea behind it is it's responsible for making sure that data is in sync between the old legacy system and the new system. So if you're migrating off that DB2 database, someone makes an edit to an account record, that can then go back down into the legacy system, or vice versa. If there's a new account that's in here, someone came in the old way and updated, it kind of goes back. So you can get this slide because it's a little bit more involved on my website to see more. Next and last pattern is the serverless, the cloud, or the not on my PC. And the reason why this is, I call this a pattern, is because you have to think about it when you're building your application. Are you going to host it in the cloud? Are you going to host it on-prem? You're going to host it hybrid in both on-prem and in the cloud. So it's something to think about. And as I wrap up, sorry for all the problems before, but like I said in the beginning, there's 3 things I wanted you to get out of this talk. One is I'm trying to give you a toolbox of ideas of all the different application patterns there are to build your application. Remember, not everything, just because you have a hammer, meaning just because I have CQRS, everything has to be that. There's a right place for all those patterns. So I know we're just about out of time. If there are any questions, feel free to ask them. If not, have a great day. Enjoy the movie. Sorry for the, oh yes, right there, you.
Where does the MCP fit again? Is that like a plugin?
That's more of the plugin architecture. So it allows you to import data from other groups and everything.
It's basically LLS plugin.
Exactly. That's exactly what it is. Cool. Enjoy the movies.